Alright, we're on section 613 now, called Flowcharts for Congruence. That was a great underline. And again, it's more of the same. In fact, this is probably, it's just extra practice. Now we're just using flowcharts. This is probably how we should have started, because now you can actually see it really come into play here. We did this in 611 because I kind of skipped over the similarity, so this really shouldn't be new. The only thing that will look different is this thing called corresponding parts of congruent. This should keep going. Just say corresponding parts of congruent triangles are congruent. It stands for CPCTC, or CPCTC is the acronym. And we'll go over that at the end of this. Excuse me. Okay. Use a flowchart to show that the triangles below are congruent. So they tell you they're congruent. I guess you have to go with that for now. Let's go and check that out. We have actual letters here too, labels, which will help us out. So QP is congruent to T, I guess that's an S, TS. Okay? Awesome. Boom. That's true. Angle P is congruent to angle T. Now these are givens, right? If you want to give a reason for it, you'd say given. And finally, you have one more, and we have to figure it out, and we have to label it. Well, this R angle, it cuts off into these two congruent vertical angles, and they're congruent. But you can't just say angle R is congruent to angle R. This is PRQ and SRT. So angle PRQ is congruent to angle SRT. So we have three facts here, and if this is enough to say conclusion that boom, one's congruent to the other, we have a side, an angle, and an angle. Or if you reverse that, angle, angle, side. We can use angle, angle, side to justify two triangles are congruent. So how do we match them up? Well, make sure that whatever lines up with the P, it should be angle T, right? Because they're congruent. So T should go first. And then it goes to Q, so it goes down the side length of 6. So T should go down the side length of 6 to S. So S, and finally the R matches up with the other R. And that makes sense because they have the same angle measurement. So again, this order is everything. It tells us everything about these triangles and where they correspond. And that corresponding parts thing will be so important when we do this later to prove other things. Number 22, determine whether the triangles are congruent, similar but not congruent, or not similar. So you have to determine now. You're not just saying show that they're congruent. They might not be. If you claim triangles are similar or congruent, use a flowchart justifying your answer. So here we go. These are parallel lines, not congruent. They could be, but we don't know that. We just know they're parallel. Because of that, this line which cuts through both of them allows me to say that this angle is congruent to that angle because those are alternate interior angles. So I'm going to go ahead and say angle DCA, that's this one right here, is congruent to angle BAC because alternate interior angles are congruent. Okay. Now there's another one right here. If I drew something right there, that would give this guy and this guy, but that doesn't really help us very much. It gives us the supplementary angle. Nothing to say there. We do know that angles B and D are congruent. Good stuff. That's a given. I'll just write given. Do we know anything else? We know those are parallel, but that only helped us find that. We know this is congruent to itself. So I'll put a few markings there. AC is congruent to itself by the reflexive property, and that's shared in both triangles. I'll say reflexive. Okay? So we have an angle, and a side. An angle, and a side. By angle, angle, side, we are able to not only determine, angle can determine they're similar, but angle, side can determine that they're congruent. So ACD is congruent to, match them up appropriately, C, that side to it, A, then B, that side opposite D. So CAB, cab. ACD is congruent to triangle CAB because of angle, side. And notice why this is an angle, side, angle. I know I could go angle, side, angle, but they need to be in perfect order. For angle, side, angle, it would have to be angle, side, then angle right there. And angle, side, angle right there. This is angle, angle, side because it goes from one angle to the next and a side immediately following. So that's just kind of what that means. Okay, hint, look for congruent angles on this one. Okay, I found two right here. G and I seem to be congruent. They seem to have boom, boom. So that's a given. Always look for those givens. They're very nice. Let me scroll down here. 5 isn't congruent to 4. That doesn't do us much help. H gives us vertical angles right here, which vertical angles are always congruent. Let's look at what that letter was up there. F. So angle FHG is congruent to angle JHI. Vertical angles are congruent. That's my reason down there. Do we have anything else? Any sides congruent to themselves? Nothing to say there. No parallel lines. We might be finished. If this was a 5 and not a 4, that would be enough information to say that these are the exact same triangle. But because this is a 4, we can actually say these are not the exact same triangle. However, and this is a big however, we do have two angles that are congruent, two pairs of angles. So we can actually claim similarity. We can say by angle, angle, these triangles are similar. So angle, angle can justify something. It doesn't have a side ratio of 1 though, right? 5 to 4 is not 1. And these are the corresponding sides. So FGH will be similar to, JIH, right? J going down the 4 to I to that congruent angle like that, and H, the last congruent angle. So let's go down. JIH. Oh, I didn't even see this stuff down here. So these guys are similar, and these guys here were congruent. So again, similar means they have congruent angles, but not necessarily congruent sides. Okay? And the back page, they give us a hint here. They say draw the two triangles separately. I love to do that myself, and here's a big reason, because you're going to have a 3 that you want to mark on both of these triangles. So let's do it separately, and let's put them the same direction. So I have this, I'll just draw them like this, and they're going to look like they're the same size, but they really aren't. So here's TUS, and to match them up, match up the right angle with one another, that guy with that guy. So I'm going to match this one up over here, right angle. If this is 6, then this is T, and this is V. So notice, you're going to have a T sharing here, and you're also going to have a U sharing here. This is 3, and this is U. Between U and S is 2. Between T and U is 3. So we can already see this, and we can already know that these triangles aren't congruent, because 3 doesn't match with 6. However, maybe we want to see if they're similar, right? Let's do a side ratio test. Let's do TU over VT, 3 over 6. That gives us 1/2. For that side ratio. How about SU over UT? 2 over 3? Well, that's just 2/3. These are not the same side ratio. Therefore, they are not similar. You could have also used Pythagorean theorem to figure out what the hypotenuse was for both of these, but you still would have found a different side ratio as well. So again, these are not similar. Facts, though, let's start listing some facts, because this is what we were supposed to do. Angle U. Well, in the brand new triangles here, I should say. I'm sorry. Let's do this again. Angle SUT is congruent to angle UTV. The right angles are congruent. And you can say, you can go ahead and say TU is congruent to itself by the reflexive property. Okay. But this ends up giving us all that we can have, an angle and a side. Nothing else is shown to be congruent. So angle side gives us nothing. We are not able to say anything about SUT being congruent or similar to UTV. Nothing, 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 nothing. We probably shouldn't even write anything in there. They are just not. Okay, they hint us at Pythagorean theorem for this one. I guess they want us to say, can we see and say whether or not these are congruent? Now we can use HL to prove that these guys are congruent, right? Or we can use side, side, side once we figure out that last side. Let me redraw this one here to make it right side up. I'll have P as my right angle, R as that tall one, and Q going here on the short side. I have a 12 and a 13. Okay, the things that we know. Angle P is congruent to angle L. That's a given. They're both right angles, and with them being both right angles, that can help us not only on angle side angle, or I'm sorry, not only help us do something like angle side angle or side angle side or something like that, but it can also help us because we can possibly use HL. So let's figure that out. RQ is congruent to KM. Those are the hypotenuse. I don't know what the plural is for hypotenuse, actually. And finally, okay, we don't know if RP is congruent to KL, or we don't know if ML is congruent to QP. But if you use Pythagorean theorem here, which is a squared plus b squared equals c squared, and we figure out what one of these things are, maybe that'll help us. So let's go ahead and try that. Let's figure out what KL is. I'm going to call that, well, let's call it B. Okay? So I'm going to say 5 squared plus b squared equals 13 squared. Now we have to solve for b. Okay, 5 squared is 25. 13 squared, take out your calculator for that one, but it's 169. So when we solve for b, we're going to say that b squared is 169 minus 25. So b squared is 144. If you take the square root of both sides, you get b is 12. So b here has length 12, and this RP is 12 as well. So we have just found out by Pythagorean theorem that RP is congruent to KL. You can say by Pythagorean theorem if you want to, anything you need to justify that. But now this doesn't necessarily prove that triangles are congruent, but let's check it out. We do have an angle, a side, and a side, an angle, a side, and a side. We can't use that to prove it, right? No ASS, but we can use HL. And what that says is when you have a right triangle, with here's your right angle, if you have your hypotenuses to be congruent and one set of legs to be congruent, then the other leg must be the exact same as the other one. So these must both be 5s. And if that's the case, you can say side, side, side. But this is HL, saying hypotenuse-leg we found. So I don't know if you want to say these are congruent. You can say that these are right angles, though, if you want to as well. So KLM is congruent to, got KLM RPQ. I'm sorry, that's triangle. I should have said triangle here as well. You have to get used to saying that stuff. Reason, HL. So these are congruent. They're also similar, but congruent's the more important, it's the more specific one. Okay, here's the last thing that I want to talk about, and it's called CPCTC. Corresponding parts of congruent triangles are congruent. Alright, you're given that 2 triangles are congruent. Now, they're not drawn. I can draw them for you. In fact, I'll use the shape tool and help you out a little bit here. Let's just do triangles. Let's just make them look like this guy, and let's pretend that this is the exact same thing. They look close enough to me. Okay, and let's label these, what did they say? UVW and XYZ. Okay, now these triangles are congruent. So I want you to keep something in mind. What can you conclude about the sides and angles of u, v, w, and x, y, z? Write down 6 congruent statements involving side lengths or angle measurements that must be true. Hint, draw a diagram as a visual below, so we did that hint. So here's what's up. These triangles are congruent. They tell you that it is. And as we've seen in every single case here, when triangles are congruent, that means they're the exact same triangle. They have the exact same side lengths, and in fact, even angle measurements measure up. They're not given to us, but the fact that we know that they're now congruent means that they are. And that's what CPCTC is all about. If I know that these two triangles are congruent, then that means that their corresponding parts are congruent. That means UVW congruent to XYZ. Angle U must be congruent to angle X. That is a must. So angle U and angle X must be congruent because these triangles are congruent. And these are the corresponding angles. I go to UV right here. This must be congruent to XY for these to be congruent triangles. So XY is written here. Move this up a little bit. Angle V must be congruent to angle Y for congruent triangles. I know this is kind of like duh at this point, but just roll with me here. VW must be congruent to YZ. Angle W, take a guess, shot in the dark, angle Z. And finally, UW is congruent to XZ. Now the reason behind this is called CPCTC. Let me write it the other way actually. I'm going to write this out. In fact, I'm going to type it for you. This will be fun. This is oh, this will be big. Alright, this is CPCTC. This means, let me make it a little smaller. This means corresponding parts of congruent triangles, I can't spell, are congruent. You can see the CPCTC, corresponding parts of congruent triangles are congruent. So what that really means is that you might be given some information, and instead of proving that triangles are congruent, you might use your proof that the triangles are congruent to prove that a final side length that you weren't given before is congruent. So for instance, over here, when we figured out that this side length was 12, I said because these two triangles are congruent, this side length here must be 5. There's no other thing it can be. Now that's because of HL, but it's also because of CPCTC. I already proved the triangles are congruent, so I can fill in the rest of the information, just like these angle measurements. I don't know what they are. I can use trigonometry to figure them out, but they must be congruent. Same with these guys. And that's all what CPCTC is. So once you prove triangles are congruent, or if they give that information to you, then you know that there are identical parts, and you have to match them up. UV and XW, or UV and XY, angle W and angle Z, etc. So that's all that is, and this is, hopefully this is enough practice in 611, and this stuff really makes sense. Eventually we're going to get into 2-column proofs where it's the same thing as a flowchart, but you list the statements on one side, the facts, and things like reflexive, the reason behind it, you list on the other side, just like a T-chart. We'll do that another day though, so hopefully you liked this lesson, and if you have any questions, always ask in the thread.